In this precalculus algebra video, we're going to solve a linear system using matrices and what's called Gauss-Jordan elimination. Okay, so let's do an example. Solve using Gauss-Jordan elimination. So first of all, this is a linear system, and what we're going to do to begin with is we're going to put this in matrix form. And what you do is you simply identify all the coefficients. So I see a 1, 1, 1, negative 1, 2, 3, 17, the constants as well, 4, 2, negative 1, 0, and negative 7. And you write them in what's called matrix form. So let's write that over here in what's called the matrix. So you do this huge bracket, and then you write the coefficients in a row. So 1, 1, 1, 4. There are no variables, just the constants. Negative 1, 2, 3, 17. And then 2, negative 1, 0, negative 7. Okay, that's called the matrix. It's simply a rectangular array of numbers. It's just a way of organizing numbers that allows us to solve the system in a really methodical way, as you're going to see. Anyway, it's called an augmented matrix. Let's write that down. You'll see that language. And all it is the matrix of coefficients for that linear system. And our goal is we're going to use what are called elementary row operations. So we're going to do things with the rows of this matrix, right? So this is the first row, this is row 2, and this is row 3. And we're going to use those operations to get this matrix into the following form. It's going to take a few steps. We're going to get into the form 1, 0, 0, and then some number, and then 0, 1, 0, some number, 0, 0, 1, and then some number. Okay. Now this is called the reduced row echelon form. Reduced row echelon form. And this system right here, the columns correspond to x, y, and z, just like they do here, right? This first column is for x. As you can see, these are the coefficients. These are the coefficients for all the terms containing x. This corresponds to y, and this corresponds to z. And then the last column is corresponds to the right-hand sides of the equations. And the solution that we're going to be able to read off at the end is going to be the same as the solution to the original problem, which is, of course, the solution to this system. And we're going to see how this works, but we have to first identify how do you get from here to there. What are the elementary row operations you can use to convert this matrix to that matrix? So let's go ahead and identify those now. So when you use Gauss-Jordan elimination, here are the row operations that you can use. Well, here are the elementary row operations you can use. And when you get your system into reduced row echelon form, it's said that you're using Gauss-Jordan elimination, or that's what you're performing. So here's what you can do. You can add a multiple of one row to another row. You can multiply a row by a non-zero constant, and you can interchange two rows. Okay, so these are what we're allowed to do to that original matrix to get it into reduced row echelon form. So let's see how that works. Let's start with that original matrix and perform these operations until we get it in that final form. So here's the original matrix. So if you look at that final form, let's do a little flashback to the original page. If you look at that final form, it's got ones occurring progressively to the right, and then zeros below the ones and zeros above the ones. Okay, so that's ultimately what we're trying to do. So let's go back to the problem we're working with, which is basically this original matrix. So how are we going to get this matrix in that form? Well, don't we want that to be a 0? We do, right? So what we're allowed to do, one thing we're allowed to do is add two rows together, right? We can add a multiple of this row to the second row. And what we're going to do is we're going to replace that second row with the result. So the first row is going to remain as it is, and the second row is going to be replaced by the sum of those two rows. And so we'll write that down. We're going to take R1, that is row 1, this top row, and we're going to add it to row 2, and then we're going to replace R2 with the sum. So this says that R1 plus R2, that is the sum of these two rows, is going to give us the new row 2. And then the row R1 is going to remain as it is, okay? So here's what we get. We get 1, 1, 1, 4, right? Top row remains the same. But when you add these together, 1 plus negative 1 is 0. 1 plus 2 is 3. We are replacing that second row with the sum, right? 1 plus 3 is 4. And then 4 plus 17 is going to be 21. Now we also want a 0 here, right? Because we want a 1 with zeros below it. So now we're going to take negative 2 and multiply it by that top row. And the reason we're doing that is because negative 2 times 1 is negative 2. And when you add it to this, you get a 0 right here. So we're going to take negative 2 multiplied by R1, and we're going to add that to R3, and then we're going to replace R3 with the result, with the sum of those two. So negative 2 times 1 is negative 2, added to this is 0. Negative 2 times this is negative 2, added to that is negative 3. Negative 2 times 1 is negative 2, added to this is negative 2. Negative 2 times 4 is negative 8, added to negative 7 is negative 15. Okay, so it's looking good, right? We have a 1 with zeros below it. Now ultimately we want a 1 right here and a 0 below it. Let's get a 0 below, let's get that 0 here first, and I'll do that by simply adding these two rows together. So I'm going to take R2 and I'm going to add it to R3, and I'm going to replace R3 with the sum. So we write that in the following way, that R2 plus R3 is going to give me my new R3, and that looks like this. Top row coming along for the ride at this stage, 1, 1, 1, 4, 0, 3, 4, 21, so 0, 0, 2, 6. Okay, and then yes, we want a 1 right here, but we also want a 1 right there, and this one's easier to get because I can simply multiply the bottom row by 1/2. I can that's one of my elementary row operations, right? Multiplying a row by a constant. So I'm going to take 1/2 times R3 to give me my new R3. So 1/2 times R3 is going to give rise to my new R3. And what do I get when I do that? Well, top row is still 1, 1, 1, 4. Middle row is going to be still 0, 3, 4, 21. Bottom row is going to be 0, 0, 1, 3, right? Because I'm simply multiplying each of these by 1/2. So 0, 0, 1, 3. Okay, now I don't want to, I do want a 1 here, but I don't want to simply multiply these all by, or divide these all by 3, or multiply them by 1/3, because that'll give me a 1 here, but that'll give me 4/3 there, and I don't really want a fraction there. So what I'm going to do instead is, I eventually want zeros right here, so I'm going to get those zeros first. So what I'm going to do is I'm going to take this row, I'm going to multiply by -4, and I'm going to add it to this row, and that's going to give me a 0 right here. And then I'm going to take this row, multiply by -1, to give me a 0 right there. All right, so let's do both of those things. It's going to be negative 4R3 plus R2, and that gives me my new R2. That's the first thing we're going to do. So the bottom row is going to remain the same after we've done this, right? So it's going to be 0, 0, 1, 3, and then -4 times this added to that is going to be 0, 3, 0, right? -4 times this added to that, and then -4 times this added to that is -12 plus 21, which is 9. And then I'm also going to take -1 times this and add it to the top row. So -1, so just negative R3 added to R1 is going to give me my new R1. And it's going to give me 1, 1, 0, 1, because -1 times this added to that is 0, -1 times this is -3, added to 4 is +1. Okay, now we're almost there. Let's get a 1 right here. That means I'm going to multiply this row by 1/3, because that'll give me a 1 right there. So it's going to be 1/3 times R2 is going to give me my new R2. And I'm looking at 1, 1, 0, 1. It's going to be 0, 1, 0, 3. 0, 0, 1, 3. And then finally, let's go ahead and take -1 multiplied by this and add it to that. I'm almost there, right? I've got a 1 with zeros below it, a 1 with a 0, a 1 here with zeros above it. I just want a 0 right there to get reduced to echelon form. So -1 times this added to that is going to give me that 0 right there. So let's write that down. That we're going to take -R2, and we're going to add it to R1 to give me my new R1. And that's going to become, well, it's going to be 1, 0, right? Because -1 times this added to that is 0. And then I add them here and I get a 0. And then -3 plus 1 is -2. And the bottom row, or the second row, remains the same, 0, 1, 0, 3. Bottom row is 0, 0, 1, 3. Okay, now this is in reduced row echelon form. Now remember, these correspond to the coefficients for x. This is the coefficient. These correspond to the coefficients for y, and these correspond to the coefficients for z. And so if you convert these to equations, this top row says 1x plus 0y plus 0z equals negative 2. That means x is equal to negative 2. The second equation says 0x plus 1y equals 3. So y is equal to 3, and then the bottom equation says that 1 times z is equal to 3. That is, z is equal to 3. And so our solution, our ordered triple, is negative 2, 3, 3. And that's the advantage of getting it down to reduced row echelon form, is that you can then just read off the solution because x equals that, y equals this, z equals that. So that's how you solve a system using matrices. And when you do this, when you use this process, it's called solving using Gauss-Jordan elimination, right? That's if you get it down to reduced row echelon form, so you can just read off the result. Okay, until next time.